Hello guys, this is Hariharan. In today's video, we will be seeing about agent-to-agent communication. First, I will explain you the core concepts of agent-to-agent communication using a whiteboard, and after that, I will deep dive into a mini project which I made using a agent-to-agent communication protocol, and I will show you a small demo. Now, let us get into it. Imagine you built an agent using Google ADK, and your colleague built an agent using LangGraph, and your manager built an agent using CrewAI. So let's say if your agent wants to ask something to the agent which your manager built, there is no standard communication. So in order for your agent to communicate with the manager agent, you need to write custom code, custom APIs in order for your agent to ask whatever question it required for the manager agent, and all those communication, all those things you need to handle. This is before agent to agent communication. So agent to agent is an open standard which was developed by Google, and now it is maintained by Linux Foundation. So agent to agent is basically like a HTTPS for web. So HTTPS doesn't care if it's a Linux or Mac or Windows, or whether it is Chrome or Firefox. It's used to communicate with all of them in a single language. Similar to that, agent to agent is a single way of communication for AI agents. So as you can see from the diagram, agent to agent protocol acts as a common language for all your agents, Google ADK, LangGraph, CrewAI or any other framework. This is now adopted by 50 plus companies, and most of them are applying this in their agent to communicate with agents in different frameworks. And also it was launched in April 2025. There are actually two protocols which you have heard in Google AI agent ecosystem. So these are the two protocols. One is MCP, another one is agent to agent protocol, which we are going to see depth in this session. So most of them might have heard about MCP, which is model context protocol. So MCP is basically, it gives us hands to the AI agent, that is the tools. So it gives access to the LLM with external tools or external data. All those things is handled by the MCP, and this agent is basically, it gives the LLM an access to other agents. So it's like a phone. So let's say there is another agent and your agent needs to communicate with that agent. It's like you are calling the another agent via a phone call. So agent to agent communication acts like that. So these are two different things, and this MCP we can connect to any DB, calendars, all those things, external data. And this agent to agent we can either connect it to Google ADK itself, or we can connect to other frameworks like LangGraph, CrewAI, etc. Similar to how two people introduce themselves, agents also needs to get introduced to themselves in order for them to communicate with each other. So let's say there are two people. How they communicate with each other? They either gives their business cards, or they tells a short intro about themselves. So let's say they share their business cards. Similar to that, this agent to agent protocol also contains a agent card. So what this card does is, it tells what that agent does, what is its skills, what it supports, and what are the authentication system, and what are the examples, and what input it must be given. All those things will be given in that agent card. So this agent card is basically a business card to an agent. So it contains all the information about the agent. So you can see this URL. So in this URL, this is the agent card located. So this is the URL of the agent where the agent is being published, and we can get the agent card by using .wellknown / agent card.json. So this is the default agent card setting for agent to agent communication protocol. So in the later part I will be sharing you with a small mini project. So in that mini project I have made an agent called travel agent, and this for this agent I will be connecting to an weather agent and also a fax agent. So for this weather agent, this travel agent will know what this weather agent does by seeing this agent card. So this agent card contains the URL where the weather agent is being hosted, and also the skills which has. So the only skill which has is get weather, it gives us the weather data, and also the authentication, so which type of authentication which it needs, and also example. So example is basically like this travel agent will go through the examples in order to understand how it should ask the weather agent for the output. So in examples you can see this example, weather in Tokyo. Similar to that, we can ask weather in Chennai or weather in Paris. Like this we can ask we can give the examples in this, so that while the travel agent goes through this examples, it knows. So in order for me to get the weather data, I should ask like weather in Chennai or weather in Paris, like that I should ask. So what it does, the travel agent will ask the weather agent like that. So it will ask whether in what is the weather in Chennai, and the weather agent will give the appropriate output to the travel agent. So this agent card tells the travel agent what, where, and how to talk. So with this information, this travel agent can easily communicate with this weather agent. So this is the agent card. Now let me explain you about the task lifecycle of an agent to agent protocol. So task lifecycle is none other than how an agent A gets an output from the agent B. Whatever information it needs from agent B. So for explaining this, I will use an restaurant order system as an example. So let's say a customer needs an dish from the restaurant. So he makes an order. So once the order is placed, the restaurant, the kitchen starts working. So while it's working, they will say that we are preparing the order, kindly wait. So when the food is completed, they will say they will give the food to the customer, and they make the food as delivered. Let's say if the food is out of stock, they will just say sorry, the food is out of stock and the order is failed. Now let's say if they need some inputs, like let's say the customer says I want a steak. So the chef will ask the customer how does he want the steak. That is, the kitchen needs an input in order to cook the steak with respect to customers desires or wishes. So the chef needs to know how the steak needs to be cooked. So he will ask the customer again how the steak needs to be cooked, and the customer will say I need it to be medium boiled or fully boiled, whichever thing he prefers. Whatever he says, the chef will again get the inputs, and then he will cook the steak with respect to the inputs which the customer gave, feedback which the customer gave. So after getting it, they will complete the order and deliver the food. This is what which happens in the restaurant. Similar to that, now when an agent A asks agent B, it wants to complete a task. So the agent A will submit a task to the agent B, and the agent B will start working. When the task has no dependencies, it will easily complete the task and give it to the agent A. Or let's say if it needs something, like it need any specific information from the agent A in order to complete the task, it will again ask the question to the agent A, like I need this information, can you please give it to me. So the agent A will again give the input to the agent B, and then agent B will complete the task and return the output to the agent A. This is what happens in agent to agent protocol. So for every task, the agent A will send these things. So these are very important for the task. One is task ID, so which task it is being executed. So there might be multiple tasks, and multiple different agent can ask an agent to complete a task. Let's say there are more agents, like agent A, agent B, agent C, and all those things need agent D to complete task. So each will send a separate task ID, so that the agent D knows what it's working on and to whom it is working. So this task ID is used for this, and this context ID is basically like a session ID. So let's say the agent A is being chatting with agent D. So this agent D must know the previous conversations of agent A in order to answer the questions efficiently. So this context ID is like a session ID. So what it does, it stores all the previous memory information which the agent A and agent D speaks in the memory. So this is the context ID is used for. And next one is state. This state is used for static memories or any other thing it needs to store specifically. All those things state is used. And this messages like are the user inputs. So whatever question the user asks or anything, the prompt which he gives, all those things will be stored in the messages. And the artifact, this artifact gives whether the input required, needed, or the task is completed, or it failed, or it cancelled. All those information will be stored in artifact. This is the task life cycle of a agent to agent protocol. Now let me show you the full A2A communication flow. So this is a small mini project which I built for you guys to understand what is agent to agent communication. So now I will explain the entire project diagram, or what's the outline of the project. So the user sends the input to this travel agent. So this travel agent is built using Google ADK, and also the model which I am using is Gemini, and this runs on port 8000. Or if you want to deploy it to Cloud Run, you can also easily deploy it to Cloud Run. So for now I am just using local host to deploy them and show you. This travel agent communicates with weather agent and travel fax agent via agent to agent communication. So this is a separate agent and this is a separate agent. And the thing which you must notice, this weather agent is built using ADK, and this travel fax agent is built using LangGraph, which is a different framework other than ADK. But using this agent to agent, we can easily communicate with two different agents, I mean ADK agent and LangGraph agent. And also this travel agent, this route agent, doesn't know what these sub agents are. I mean, it doesn't know how the weather agent is implemented or how the travel fax agents are implemented. The only thing which it gets the information is the agent card, so which I explained in my previous slide. So only this agent card is available to the travel agent, and with this agent card it asks the weather agent as well as the travel agent for the outputs and gives us the output which we need. So the next one I will show you how exactly the travel agent communicates with this weather agent. So this is the full zoomed in view of how two agents talk via agent to agent communication. And this agent to agent protocol uses JSON-RPC 2.0 communication, not REST, because REST communication is stateless. For this type of agent to agent communication, this agent B, I mean this weather agent, must know the previous conversation of the agent which that talked to in order for it to give us better response. But this REST is stateless, it doesn't know the previous responses. So by using JSON-RPC, we can send the context ID, I mean the session ID, the task ID, all those things informations we can send and make this agent to agent communication as a stateful communication. So you can see first the get, first this travel agent gets the agent card. So this is the first thing it will do from the weather agent, and the weather agent will send the agent card JSON to the travel agent, and the travel agent now understands what this weather agent is and what it is capable of and how it can send the input to the weather agent. And after that it will send the input to the weather agent, which is a JSON-RPC 2.0 communication. So it will send the input in the JSON-RPC format, and it will get the output from the JSON-RPC, which says that the state is working. And after, when it's completed, it will again send the state is completed. So all those things will be stored in artifact in the JSON response. Oh, this is how agent to agent communication works under the hood. These are the two ways to expose agent to agent communication. Path one is Google ADK. So while exposing a Google ADK agent as an agent to agent communication, that is generating the agent card, all those things is very easy. You just write the agent.py and you write the agent.json file, and then you can easily call ADK API server underscore A2A. By calling this, you can easily host this agent as an agent to agent communication feasible agent. And next, for any other framework, you need to write the agent, and you need to write custom agent executor. This agent executor will be used by A2A to call the agent, and also A2A starlet application. So what is this application is? This is a agent to agent SDK HTTP server for the other agents to communicate. So in Google ADK, creating an agent to agent feasible agent is very easy, but for any other frameworks is also easy, but it just requires a little amount of work. In ADK we have inbuilt methods with which we can connect the root agent to the remote agents. So this remote A2A agent function is used to connect the remote agent, that is the weather agent and travel fax agents. These two agents we can easily connect to the travel agent using this remote A2A agent, and we can add this remote A2A agent as a sub agent to the root agent. And now this root agent, that is the travel agent, doesn't see this remote A2A agent as a remote agent, but it sees them as a sub agent. It doesn't know what this remote A2A agent does in the hood. It only sees them as a sub agent. But this remote A2A agent, internally what it does is does a HTTP and JSON-RPC communication commands. This is what it does internally, and connects to the weather agent to get the output. Now this is the agent to agent ecosystem. We have seen till now all the capabilities and also how to use agent to agent communication by connecting ADK, LangGraph, CrewAI, any framework, etc. by using agent to agent protocol. So this agent to agent protocol uses HTTP, JSON-RPC plus SSE for connecting to other agent and giving us the responses. So now I will show you an example code, which I have also explained you the architecture of what I have built. So I will now show you the code and a small demo on how agent to agent communication works, and how a root agent is connect with other remote agents and gives us the required responses. Now let us dive into the code. So I have made a separate folder called A2A, and inside this folder I have kept the code for my joke agent and weather agent and also travel concierge agent. So this travel agent is basically the main agent which will call this joke agent and weather agent, which are being hosted in 8001 and 8002 ports. So these two agents will reveal the agent cards, and this travel agent will read those agent cards and use this two sub agents as however it wants. Now let me go in depth into the joke agent and weather agent code in order to understand what happens. So first let me go through the joke agent. So this main.py is the file in which I defined the agent card and A2A starlet application. All those things are defined in this main.py only. So I will go through step by step how it is we will define. And this joke agent is a LangGraph agent. So first we need to define the agent skill. So what are the skills the agent has? So you can see it has the tags are travel, fax, destination, tips. So this tags are basically, it represents the simple words about the agent skills. So what this agent skill is about: travel, fax, destination, tips, all those things. And also examples. So examples includes the list of prompts, example prompts which the agent can answer. So let's say, tell me interesting facts about Tokyo. What should I know before visiting Paris? Give me fun facts about Brazil. So these questions the agent will answer. So by feeding these by seeing these questions, the caller agent, I mean whichever agent tries to sees the catalog, I mean the agent card, will know that how to give this agent the prompt so that it can give us the appropriate answer. So for understanding these, we are giving an example section. And next one is, we are now structuring the agent card with the name, description, a simple description, and also the URL with the host and port. If you host it in Cloud Run, you need to give the Cloud Run URL, and also the skills which we defined above, we are providing the skills, and also the capabilities, we are keeping the streaming is true because we need a two-way communication, so we kept the streaming as true. And also the default input, we will give the input mode is text, and we also will give the output as text. So we are setting the default input modes and output modes as text. Next one is executor. So this executor will be called by A2A. So we are using a travel flags agent executor. Before, while I explaining the agent to agent communication, I told you while we are using agent to agent for different frameworks, we need to write a agent executor separately. So that's the agent fax executor. Next one is request handler, that is the tasks. So for completing the task from agent 2, we need to provide the tasks to the agent. So for that we are using in memory task store, that is we are not store the tasks are basically stored in the RAM, so we are using the in memory task store. And then by using this agent card and executor handler, we are starting the agent to agent starlet application. So this starlet application is basically a HTTP application. So this agent to agent now is hosted on the local host and at the port 8002. So it's live. By using the UVCon, we are running the server. Now let me show you the agent executor. I will just explain you the outline of the code. Now this class travel fax agent executor is the class. So you can see this agent, I am inheriting it from the agent executor class in the A2A. In this class you can see an init function. In this I am setting the agent as travel fax agents. This travel fax agents is the LangGraph agent. I will explain this after explaining the agent executor class. So in this agent executor class you can see this execute function. This execute function will be called by the A2A for running the agent. So it gets two arguments. One is the context. In this context you will get the input, task ID and also the context ID, and in this event you will get the tasks actually. So this event is basically the in which you will stream back the response to the caller. So in this task updater we are updating the tasks, and then after updating what we are doing is submitting the tasks. While in explaining with the whiteboard, I told you we have to submit the task and then it will start the work. So first we are submitting the task, and then after that we are starting the tasks. And here is in this we are just streaming the queries and getting the output, and with respect to the output we are updating the artifact. If the task is complete, we are updating it is complete, so that the agent to agent communication will stop and the caller agent will use the output. And then now this is how the execute function work, and this is the cancel function. Cancellation is not supported by this agent, so for now we are just using an unsupported operation here. Now let me show you the LangGraph agent which I built. So this is the LangGraph agent. For state I am using the annotated state, and I am adding the messages in the list. Since we need the conversation history, we are adding the messages to the list. And this is the system prompt. This system prompt basically says what the agent must do always. And this is the travel agent class. For LLM I am using Gemini LLM, and I am giving the API. I have given the API key for the Gemini model, and now I am building the graph. I am just using a state graph, and for this graph I am using only a single node. You can see I am using only a chatbot node, a single node, and then encapsulating it with the start and end edges, and then I am building the graph. You can see this chatbot node implementation. In this I am sending the messages as the system messages plus the messages which, and this messages is the messages which the agent sends to us via A2A. And then by prepending with the system prompt, I am invoking the LLM with these messages and then sending the response as output. This function stream is being called by the executor actually. In this you can see, in this executor you can see the stream. So the executor will call this stream function. In this stream function you can see we are invoking the graph. For invoking the graph I am using the messages as the user message, the query which the agent to agent communication sends us, and also the session ID. Why we are using session ID is we need separate conversation for each calls or each user. so we need separate conversation histories. And after getting the response, we are just sending the response. For running this application, I'm just calling python joke agent. I'm just calling this joke agent, and this main.py will automatically run, and it will hosted in the port which I mentioned. Now I will show you the A2A exposed weather agent. So inside this remote agents, I have defined this weather agent. So this agent.py is a simple weather agent which I made. So it uses the get weather tool. By using open Meteo API, I'm getting the weather information and returning this information as a JSON format. And this agent is a simple ADK agent. By using Gemini 2.0 Flash as the model, and using the get weather tool which I defined using the open Meteo weather tool, I'm defining this weather agent. And then this agent.json, I have defined this agent.json file. In this JSON file, you can see the streaming capabilities are true, and the input modes are text for both input and output, and the description is a simple description. It says it provides real-time weather data, and also the preferred transport JSON-RPC, because we need the task id, context id, all those things we need. For that purpose we are using JSON-RPC. And for the skills, you can see the examples as what is the weather in Tokyo, is it raining in London, how cold is it in New York, all those things. And also the tags as weather, temperature, climate, city, everything is related to weather. So by defining this agent.json, we can this agent.json will be sent to the caller, actually whichever is calling this weather agent using A2A, they will get this agent.json. Since this is an ADK agent, you don't need any executors, all those things. You don't need any task handlers, you don't need to define anything, because all those things will be handled by the ADK itself. So in this readme, you can see for defining this weather agent, we ADK itself has an inbuilt command, that is ADK API server underscore A2A, and the port is 8001. By giving this single command, ADK itself will create the execution handlers, task handlers, everything, and wire it up with the agent and host the agent in the required port with the agent.json file. Now let me show you how we can call these two agents using the another agent, which is travel agent. So in this travel agent, I have defined a simple travel agent using ADK itself. In this, the model is Gemini 2, and also name, and the instruction is simple instruction which you can go through. And also for this sub agent, we are using the weather remote agent and also the travel facts remote agent. These two agents, this agent is the A2A exposed ADK agent, and this one is A2A exposed LangGraph agents. So these two are different agents. Now let's see how we are connecting these two to the root travel agent. So by using the remote A2A agent function. So in this function, ADK internally handles the HTTP connection, also the JSON-RPC connection, all those things ADK itself handles. So that this root agent simply sees these two agents as the sub agent itself. It doesn't know internally what it happens. It just sees them as an sub agent and just make a call to those agent. So in this weather agent, you can see that for the agent card, I am giving the URL as the agent card URL. That is, all the agent cards will be stored in the agent hosted URL plus /well-known/.agentcard.json. So I am giving this agent card as a URL, and all those agent URL, execute URL, everything will be given by the agent card itself, because in the agent card we will define a URL, right? So from that URL, it will take the URL required to call the agent. Similarly, I am using the travel remote agent also in .well-known agent card. Since in this I have hosted the travel agent in the the travel fact agent in the 8002 port and the weather agent in the 8001 port, so that I have given this like that. And with this, we can easily call those agent and use it. Now let me run this agent and show you a small demo. First, let us start the weather agent. I will copy this command and paste it in the terminal. Yeah, you can see that it has started in the 8001 port. Now I will copy this one. I have opened a new terminal and I will paste it here. Since you're already inside ADK course, I will just remove it. Yeah, now you can see this joke agent is being run in 8002 port. Let me open another terminal to run the travel agent to test our sub agents. Okay, let me copy this and I will paste it here. Okay, now this travel agent is also started. In select this agent, you select travel agent and you have get this. Let us simply type hi, what you can do. Let's wait for some time. Yeah, it's saying that I am a travel concierge ready to help you plan amazing trips. So let us ask the weather information. What is the weather in New York? You can see it's getting transferred. Yeah, it's saying the weather in New York is overcast with temperature of 7.3 degrees Celsius and wind speed is 1.5 km per hour. In the events, you can see it has called the weather remote agent, and it has given, and the weather remote agent has given us the response. So in order to inspect that, we can actually go to this terminal and see. Yeah, in this you can see that this remote agent, I mean the terminal one which we have run the remote agent have been called, and it has sent the response via the agent executor. In this you can see ADK itself has implemented the agent to agent executor, all those things it itself has implemented. Now let us test the next agent. So in this I have asked a fun fact about Brazil, and you can see it's been transferred to the travel fact agent, and you can see here it been transferred to travel fact agent, and it has given us some fun facts about Brazil. So let's inspect whether it's been called or not. Yeah, in this you can see that the content, context ID, everything has been given, and also this LangGraph 8002 port has sent us the message. So in this, with this we can verify that the agent to agent communication has been successfully completed. You can actually download this code from GitHub. I will share you the GitHub repo. You can download this code and try it yourself, so that you may get the idea how this agent to agent communication actually works. Thank you.